So section 3.4 is called the chain rule. So now we're progressing to functions that have the composition of two functions. Okay, so the goal is to find the derivative of a composite function. Basically, you have an inside and you have an outside. So this function, the outside function I would look at is the square root, and the inside is x squared plus 1. Okay, so in order to do this, there's really two different functions going on. Here's the chain rule. So the chain rule is used when you have an inside and an outside function. Technically, it's when you have the composition. So composition, remember, is f of g of x, g of f of x. Okay, where f is the inside function. In this case, g is the inside here. Okay, so in this problem right here, I could say the inside is x squared plus 1, the outside is the square root of x. Okay, so the chain rule is saying if they're both differentiable, then the composite function, remember that is the same thing as f of g of x. So that notation is f of g of x. Okay, defined by right there, f of g of x is differentiable at x, and f prime is given by the derivative of f at g times g prime. Okay, the easiest way to explain this is you're going to do the derivative of the outside function. You're going to leave the inside the same. So I'm going to say at the inside, all that means is leave the inside the same times the derivative of the inside. Okay, that's the chain rule. You do the derivative of the outside. So first you do the square root. Then you would do x squared plus 1. So let's do that problem. Okay, so the derivative of this would first be the derivative of the square root. Remember, this is the same thing as x squared plus 1 to the 1/2. Okay, so the outside function's derivative would be 1/2, and this is where I mean leave the inside the same. So I'd have x squared plus 1 in here. So it's 1/2 times x squared plus 1 to the negative 1/2. That's normal. Okay, times the derivative of the inside function, which would be times 2x. And then I could simplify this. The 2's would actually cancel, so this would be equal to x over the square root of x squared plus 1, or x times x squared plus 1 to the negative 1/2. Okay, so derivative of outside times derivative of inside is really what we're doing. Okay, now next couple examples. So instead of multiplying this out, okay, to the 4th power, I can do the derivative of the outside, which would be bring the 4 down, leave the inside the same to the 3rd power, and then times derivative of inside, which would be 2x minus 1. So there's the derivative. I'm not going to multiply that out. There's no need to because there's no sum or difference. It's just a product with the chain rule. So I don't need to multiply this out to simplify. Okay. Next one. Okay, first I'd write this as 5 times 1 minus x squared to the negative 3/2 if I just rewrite this as an exponent. We've done that before. Okay, now I'm going to do the derivative of the outside, which would be the negative 3/2 power, so bring that down. So I'd have negative 15/2 times, leave the inside the same, subtract 1, so I'd have negative 5/2. Then I'd say times the derivative of the inside, which would be negative 2x. If I simplify that a little bit, the 2's are going to cancel, and I would just have 15 x over the square root of 1 minus x squared to the 5th, if I write it as a root. Okay, because the 2's cancel, the negatives cancel, so I'd have 15x over that. Okay? Next one, sine of x squared. So the outside function in this problem, sine. So the derivative of sine is cosine. So I'd say cosine, leave the inside the same, times, 2x. Or I could write it as 2x times cosine of x squared. Okay? Next one, now this is really, really common. The next one's actually saying what? Sine of x quantity squared. Okay, see the difference. Number 3, it's x squared. That's the inside. Number 4, it's sine squared. So the squared is the outside function, and the sine is the inside function. Okay, so I would bring the 2 down, 2 times sine, times derivative of sine, which is cosine. Okay, so the outside is the squared power, so I do that first, and then the inside is sine, the derivative of sine is cosine. Okay, next one I have tangent of 2x squared plus 1. So derivative of tangent is what? Secant squared. So I'd have secant squared of, leave the 2x squared plus 1, okay, times derivative of inside, which would be 4x. Okay, again, I could write the 4x in front so we're not confused, and write it as secant squared of 2x squared plus 1. Next one, I'm just doing a lot of examples here, okay? The, let's say, outside function in this problem would be e, and the inside would be sine of x. So first I would do the derivative of e to the x is e to the x. So the derivative of e to the sine would be e to the sine, times derivative of sine, which is cosine. Derivative of e to the anything is e to the anything, and then times the derivative of whatever your power is. Okay, next one is sine of cosine of tangent. So the most outside function would be sine. So derivative of sine is cosine, and then I leave everything else in here the same. So it's just going to be really long, guys, okay? Times derivative of cosine is negative sine, and then I leave the tangent alone. Then finally the derivative of tangent is secant squared. So it's still a crazy long composite function. You start on the outside and leave the inside stuff the same. Okay. Number 8, I'll just do below that since I ran out of room. So number 8, see down here. Okay, the outside function would be what? To the 9th power. So I would, now that this is the whole fractions to the 9th power. So the first thing I'd do is bring the 9 down, and then I'd have the fraction t minus 2 over 2t plus 1 to the 8th power times the derivative of the inside, which now I'm going to have to use quotient rule. Okay, so derivative of numerator is 1 times denominator 2t plus 1 minus numerator t minus 2 times derivative of denominator, which is 2, all over denominator squared. Now I'm going to simplify a little bit. So I have 9 times this fraction to the 8th, 2t plus 1 to the 8th, times, let's say, I would have 2t plus 1 minus 2t plus 4. If I distribute that 2 up there, guys, I'll write it out. 2t plus 1 minus 2t plus 4 all over 2t plus 1 squared. So the 2t is going to cancel, and I would just have 5 there. Okay, so I'd have 5 is that numerator times 9, so I'd have 45 here, and then I'd have t minus 2 to the 8th. That would be my numerator, and my denominator would be 2t plus 1 to the 8th times 2t plus 1 squared, which I can write as 2t plus 1 to the 10th power. So there's finally a problem where you're actually simplifying quite a bit. Okay, there's my problem. I'll stick with Christmas colors here, and there's my answer. All right, next. Now I just have a problem where I'm doing what? Looking at this, I'd use the product rule, and within the product rule, I'm going to have to use the chain rule. So the derivative of the first function, I'd use the chain rule. I'd say 5 times 2x plus 1 to the 4th times the derivative of 2x plus 1, which is 2. Okay, that would just be the derivative of the first function times the second function, x cubed minus x plus 1 to the 4th, plus the first function, 2x plus 1 to the 5th, times derivative of the second, which would be 4 x cubed minus x plus 1 to the third, whoops, okay, to the third, times derivative of the inside, which is 3x squared minus 1. That's just using product rule. Within the product rule, I have chain rule. So this first term becomes 10, 5 times 2, times 2x plus 1 to the fourth, times x cubed minus x plus 1 to the fourth. Okay, plus the second one becomes 4, 2x plus 1 to the fifth, times x cubed minus x plus 1 to the third, times 3x squared minus 1. All I did was rewrote it. Now you see, what can you factor out of these two terms? So this is how I want to look at this. Here's one term, here's another. So I could take a 2 out. I could take 2x plus 1 out. And I could take 2x plus 1 to the what? To the fourth out. And then I could take x cubed minus x plus 1 to the third out. So out of the two terms, that's what I'm going to factor out. Let's see what we're left with. I'll use brackets. The first term would just be 5 times x cubed minus x plus 1 to the first. And then plus, I'd have 2 times 2x plus 1 to the first times 3x squared minus 1. Now your last step would be simplify this. Distribute the 5. FOIL, distribute the 2. Okay, and you should be able to simplify this to 17x cubed plus 6x squared minus 9x plus 3. And then I'd have all of this in front, and that would be my final answer. Okay, so when you're simplifying these problems, you want to look for common factors. After that first step, I want to look at the two terms I created. What can I factor out? No one wants to be multiplying this to the fourth out. It's much easier to factor and then simplify what's left. All right, last rule here in this section. We already know that the derivative of e to the x is e to the x. With a couple exceptions, remember, what would the derivative of e to the 4, if I could write it up here, 4x be? So it would be e to the 4x times 4. Okay, e to the x squared. Can't do that yet because it's e to the x. Tricked you. Okay, e to the 7x would be what? E to the 7x times 7. So it's exactly what it is times the derivative of that quantity. Okay? All right. Next rule, what's the derivative of a to the x? So the derivative of 2 to the x, 7 to the x. We saw this in a couple problems and I said wait. So the derivative of a to the x is a to the x times natural log of a. Now a is going to be some number. Okay? I can show you why quickly. So a to the x is the same thing as e to the natural log of a, because e to the natural log of a is just a to the x power. So if I rewrite a to the x as this, now I could find the derivative of that. So the derivative of this would be what? Using your property of e, would be e to the natural log of a times x times the derivative of this, which is natural log of a, using chain rule. Okay, which this is a to the x. So what's the derivative of 5 to the x? It's going to be 5 to the x times natural log of 5. Okay, there is your rule for a constant to the power, any exponential function where your base is not just a. I mean, I think I have a couple examples. Yep. So what's the derivative of x times 3 to the x? So I would do product rule. So I would have what? Derivative of x is 1 times 3 to the x plus the first function times derivative of second, which is going to be 3 to the x times natural log of 3. Look at these two terms. What can you factor out of 3 to the x? I'd be left with 1 plus x times natural log of 3. Okay, next one, y prime. What's the derivative of 2 to the x? It would be what? 2 to the x times natural log of 2 minus derivative of x squared is 2x. Two terms, they don't have anything in common. 2 to the x is not the same thing as 2x. So I would just leave my answer like that. All right, so that's the chain rule. Anytime you have an outside function and an inside function.